everyone, this is Miss Ward. Tonight our notes are going to be talking about centripetal acceleration, centripetal force in the circular motion unit, concept 7. So let's start talking about direction. Imagine swinging a ball overhead that's tied to a string. As you swing, you feel the tension pulling outward on the other end where it attaches to the ball, and the tension pulls in. This means that the force the ball feels is always towards the center of the circle. So the ball is being pulled outwards, but there's tension pulling it in. So the ball is always being pulled towards the center because of the circular motion. Since the ball is acted on by a force directed toward the center of the circle, it must be accelerating towards the center of the circle. Acceleration is produced whenever the speed or direction of velocity changes. We know this. We know that if you change velocity, you change acceleration. That happens all the time in linear motion. In circular motion, direction is continually changing. Every second, every millisecond, the direction in circular motion has changed, at least slightly. This also means that the acceleration is going to be referred to as centripetal acceleration, and the acceleration is constantly changing in a circle because the velocity is constantly changing, because the direction is constantly changing. So centripetal acceleration is constantly changing. We can still calculate it though. In a car, the faster you go around a curve, or the tighter the turn, the more you feel pushed or pulled to one side. We discussed this when we started talking about tangential velocity. Your body wants to continue moving one direction, but that curved motion is forcing you to move in another. Centripetal acceleration depends on both the speed of an object and the radius of the circle in which it moves. So centripetal acceleration is equal to the speed squared, or the velocity squared, over the radius. Centripetal force is different. So you have centripetal acceleration, which is the acceleration in a circular path, and then you have centripetal force, which is the force of a circular path. Because we know that F equals ma, it follows that centripetal acceleration times the mass, then equals the force known as the centripetal force. That is shown below. So the centripetal force equals mass times the centripetal acceleration. We know that the centripetal acceleration is the velocity squared over the radius. So we can replace the centripetal acceleration with the velocity squared over the radius, giving us this equation for centripetal force being mass times the velocity squared over the radius. So what do we take away from this? During circular motion, the centripetal force has a constant magnitude and is always directed towards the center of the circle. In addition, the centripetal force is always perpendicular to the tangential velocity of an object in circular motion. Now, what that means. I'm just going to show you. We're going to look at 4 moments in time. So, a moment on the sides, top, and bottom. Alright, if this object is moving in a counterclockwise, tangential velocities at those 4 spots look like that. But at any given moment, you feel a pull going towards the center, which means all of these form right angles, which is what they're saying. So the centripetal force, this is the centripetal force. That centripetal force are the inward angles. It's these arrows in blue. This is the centripetal force. It's an inward force. Okay, those are the blue arrows. Tangential velocity is the direction you feel yourself wanting to move. It's the red arrows. Okay, so centripetal force is always perpendicular to the tangential velocity of the object in circular motion. Tangential velocity wants you going straight in a tangent off of the circle. Alright, the centripetal force pulls you inwards. It is in a tangent. So let's do a quick example in which we're calculating the centripetal force. A 1,200 kilogram car rounds a corner with a radius of 45 meters with a speed of 12 meters per second. Alright, what is the centripetal acceleration? And what is the centripetal force? Okay, so our given information, we have a mass, we have a distance, and we have a speed. So to solve for acceleration, or centripetal acceleration first, all you do is plug in your speed squared divided by our radius. So 12 squared is 144. 144 divided by 45. We get a centripetal acceleration of 3.2 meters per second squared. Then it wants to know what the centripetal force is. Well, all we do to solve for the centripetal force, is we take our mass, which was 1200 times our acceleration of 3.2. You get a centripetal force of 3840. So just like I told you guys in class, these equations are the exact same. Now we're just dealing with them in a circle. F still equals ma. Acceleration is still the same. All of them are still the same. It's just a matter of changing them to circular motion now. Alright, that's it for tonight. Make sure you go on, do your whisk. If you have any questions, bring them to class, and we will take your quiz on Monday, or next time in class. Have a great night.